Hey, all, today we're going to do a quick review of the Pythagorean theorem. We've used the Pythagorean theorem a bunch this year. The first time when we were trying to find distance between 2 points. Also when we were trying to decide if a triangle was right, obtuse, or acute. And now we're going to use it to find missing parts of a right triangle. So here we have a right triangle. Remember, we know it's a right triangle because of the box in the corner. And a reminder that the side across from that right angle is always the hypotenuse, and then we call the other two sides legs. And that's something you should already know, but it's good to go over. And remember, the Pythagorean theorem looks like this. And it's important to remember that the hypotenuse is always C when we plug in, and the legs are A and B. Again, the hypotenuse is across from the right angle. And so we can plug in what we know here, and then we can solve and find the missing piece. We want to find the hypotenuse in this right triangle. So 6 and root 65 are our legs, and x is the hypotenuse. It's good to plug the square root in parentheses so you don't forget to square it. 6 squared is 36. Remember that a square and a square root cancel each other out, so we're just left with that number 65 that's underneath the radical. And now to get rid of the square on x, it's sort of like we did up here. To cancel out a square, we square root both sides, and so that missing side is the square root of 101. If you put that in your calculator, you would get a decimal. You can leave it like this for now. So this problem is very similar. It's good to identify the hypotenuse, the side across from the right angle. So x is our hypotenuse again. It's always good to write the formula every time. So 12 and 7 are my legs. I plug them in for A and B. It doesn't matter which order because addition is commutative. I can add either way. X goes in for C, my hypotenuse. And I simplify that left side. And again, to get rid of the squared on the x, I have to square root both sides. So I find out that the hypotenuse is the square root of 193. So I want you to pause right here. I want you to try this one. Make sure to identify the hypotenuse first and then plug in and solve. So if you identified the hypotenuse, it should be this one over here, the square root of 257. So I'm writing my formula, and I make sure that I plug in square root of 257 for C because it's the hypotenuse. I like to plug the x in for A if x is one of my legs. It just looks more familiar to have x come first, I feel like. The squared on the right and the square root cancel, so I just have 257. 4 squared, 16. I'll subtract 16 from both sides. And then again, I cancel out that squared on the x. I square root both sides to find the missing piece. You'll notice that square root of 241 is smaller than the square root of 257. And that should be the way it is because the hypotenuse is also always the longest side. So quick, tidy review of Pythagorean theorem and how to use it. Here's 2 questions to try. Find the missing leg or the missing hypotenuse in each of these 2 triangles. If you have questions, ask in class, and I will answer them.